module, we have designed it in a slightly different way. So first we are going to see the Indian perspective, and then we are going to see what is happening across the globe, right? Why this is important? You have metrics that are there in the AI domain, and there is something called what you do in the real practice. Why this topic is so important to us? Let's understand in a better way. There is a gap between AI prediction and clinical action. What do I mean by this? Around 68% of the AI models developed for the healthcare never reach deployment. That is a very, very big statement. And this is not given by me. This is what the Nature Biomedical Engineering has published. And less than 5% of the deployed models demonstrate a significant outcome change. And if the prediction is not followed by action, you save 0 lives. So that's very important. So the central question is, what happens once the AI prediction? That's what I mean by matching the metrics beyond the utility. Will the treatment change? Will you intervene sooner? Will a patient pathway shift? Does the team have a protocol to act upon the insights given by the AI model? This is what we are going to discuss. I start my class with a very basic example. This is the real world example from a published sepsis AI study. One model having AUC of 0.95. That means 95% of the cases were very accurately predicted, and 5% on each side they failed to predict. The outcome is 30-day mortality at admission. It's the biggest failure because there is no window of intervention. There are some cases like diabetes, hypertension, terminal cancer. I already know that the patient is going to die. So what the additional information AI has given to me? And even if I know, there is no protocol to act. So 0 change in management. And at the same time, there was another protocol, not that accurate, 74%, which I mean 26% of the cases, it failed to predict. But the beauty is, it is going to predict the sepsis in 6 hours before the clinical signs happen, before the shock happens. So the beauty is, you have 6 hours of action window. You can start antibiotics, send blood cultures. You can actually prepare an ICU bed rather than searching for a bed. And the real beauty is, it reduced the mortality by 18%. So please do not confuse accuracy with the usefulness. So today's topic, I'll give you 5 important commandments sort of thing, which you should remember whenever you are going to use any AI in your real life practice. If outcome is not matched with action, that means if I predict an event, if I don't do anything, please do not use. Clinically useless. Actionability is mandatory. That means every prediction should be linked with a protocol on how to act. If there is no protocol, no value, regardless of accuracy. The sooner I get the alert, the better it is. If it is going to tell within 1 minute you are going to have a heart attack, useless for me. I need to have some time to act upon it. And there should not be too many alerts. It will cause alert fatigue. I will talk about each of them 5 minutes each, and we are going to hand over to our international speakers. The last is net benefit matters more than how innovative it is going to be. So let us start with the section 1. Outcome is not equal to action. So what I mean to say, knowing what will happen is not the same as deciding what to do about it. I give a very simple example. Again, some of this information is given by my colleagues who allowed me to present it. It is open data. One of the hospitals, 2020, did a pilot to understand what is the in-hospital mortality. So the accuracy was very good, 80% probability, and every time it predicted, it really happened. When we asked the clinicians, what did we do differently? The answer is nothing changed. No treatment protocol attached. Too late, models became a documentation tool. This was very early part of AI. So after that, they improved significantly on top of this. So we'll discuss it later. But another model which I was going to inform you, that is AI output in MIMSC 3 sepsis model. It showed, again, the same model which I told, onset of sepsis in 6 hours. The clinician was able to administer the antibiotic within 1 hour of the alert. Blood cultures order. 74% of the times the blood cultures came positive. Fluid resuscitation started using the Doppler and collapsibility of the IVC, and ICU beds are there. The outcome is 18% reduction. Same example. I'm just telling this is what is the link between these things. Is it applicable only in clinical practice? No, in admin also people use it. How soon I can get a bed? I can predict based upon the vitals that within 12 to 24 hours, the patient is likely to be discharged or he is likely to stay back because of some symptoms. That is important, right? Especially in busy government hospitals, where I don't want to force anyone to go home when the symptoms are not healed yet. And people can act upon it. If there is too much of a rush in a given ward, automatic allocation of the nursing staff is feasible. They did it. And the turnaround time actually came down from 4.5 hours to close to 2 hours in one of the large hospital chains in the Bangalore area. So the second is prediction without action is equal to 0 value. This is another study done using a cardiac monitors, wearables. There are 2 hospitals. Hospital A and B were given the same device. In hospital A, the artificial intelligence flagged that the patient at a high risk of cardiac arrest in 2 hours time. But no team was alerted. EMR, emergency medical team, and electronic medical records were not mapped to it. Nursing staff is unsure whether to escalate it or not. When the patient arrested, standard code blue followed. So no impact. Whereas in hospital B, the same alert happened exactly in 2 hours before, but there is a protocol on it. That means auto notification, preparing the ward nurse, resident, and ICU consultant, training them, and then ensuring by doing mock drills to attend the patient at bedside within 8 minutes, doing a proper ECG to confirm whether it is a false alert or true alert. That actually reduced the number of cardiac arrests in the hospital. So every AI should be linked with a action. In another large medical college down south, smart rostering was also used to reduce the nurse fatigue, doctor fatigue, and what time you actually can relax when the load is less. So the burnt out in the nurses reduced by 31%, and medication errors in the night shifts were reduced by 24%, just by optimization. Not a very high-fi AI. It is an ultra basic AI. Ultra basic, right? So The key insight is the roster adjustment is not the prediction, but it saves the things. So that's what I mean by the prediction link. So what will decide this link? Three key rules. Who to act on, which specific patient, which bed, which department need to intervene, right? When to act, is there enough lead time, or I'm just rushing in and then just not doing any impact? Can I intervention in the window really translate into meaningful outcome either in survivals or reducing the mortality? Right? What action to be taken? So there should be a proven action for that given alert, like sepsis antibiotics. So unless you have a clear answer to these three questions, your protocol, whatever you tag to AI prediction, may not be useful. Then comes the section 3, that is lead time. How soon the AI can alert me? I give an example. T minus 12, AA flags arrest. T minus 6, AA antibiotics started. T minus 2. For some of them, where it is required, ICU is booked. And T minus 0, the sepsis is supposed to happen. So same MIMSC. I just took one study to teach how well a set protocol in a AA prediction with actionable outcomes has actually survived. I could take 10 different examples, but what I felt is what the literature has already proven. 18% reduction in mortality. That's awesome. The admin also, people have used NLP models by saving a lot of money, because all the classical history examination, the differential diagnosis, unless each and everything is mapped with your bill, the rejection of the insurance is very high. For those who are practicing in any town between 20 and 100 beds, why people get 30%, 40% deductions on the insurance is because the AI tools in the insurance will auto deduct these things. It is not that you have done something wrong. It is just because you haven't documented. So by using a proper AI tool, that is natural language, either by bot or thing, and standardizing the discharge summary and mapping it with the bill item wise, so that you don't miss any of those things. The claim rejection in few of the hospitals have reduced from 14% to 3%, and recovery of the cash is very significant. The same thing from the insurance also. No one would like to reject the insurance just for sake of rejection, because they also fear the legal actions on top. Old process, conventional, and they have already adopted natural language processes and they are trying to match. So the settlements are faster. But the problem is, because the insurance have adopted, the doctors haven't, there is a risk of high rejection rate in the next 5 years. Unless you also become equally smart like the insurance claims. Last two topics. That is alert fatigue. That's a real harm. If a model fires too often, it is going to teach the clinician to ignore it. There is a famous saying, right? There was an old story when I was a student that, there is a tiger and father and son went to a small village for, with their cattle. And son always tells, hey dad, I saw a tiger. Dad comes, no tiger. Second time, same thing gets repeated. Third time, really the tiger comes and takes away one of the cattle, but the father doesn't believe. This is a very old story. Most of us must have heard of this story. Alert fatigue is no different compared to what our grandmothers, grandparents used to teach us. And this is a published data from the USCMR system by JIMA. So I'll take you through the actual figures. The NEJM 2022 publication, 350 alerts per clinician per day. Imagine, it frustrates you. And 96% of the time, they say, okay, it's just like I click the button so that it doesn't bug me. Problem? 44%, that means almost half of the real alerts were missed. The error rate have increased. That is a real harm, right? This is what actually can happen if the alerts are too many things. In Indian context, in AIMS, they did a CDSS small pilot study. Again, this data was shared by one of my friends, which is in the public domain. The residents received 80 to 120 alerts per shift. Specificity was only 30%. Again, I'm talking about 3 years ago data, but now it is much better. So, real problem is if you give a false alert, the alert fatigue will lead you to do more harms than good. So, a prediction, admin action, clinical action, output, and alert design have to be combined together. And one of the hospitals, again on the southwestern zone, actually did it. OPD waiting time has reduced to the half. There are no empty slots for the doctors. SMS alerts were very appropriate. So, how do we overcome this fatigue? In other words, how do I design a smart alert mechanism? So I need to choose quality over quantity. How many alerts is the last point I want to hear? And how good is the alert is what I need to see. The number one rule is raise the threshold. A pulse of 90 should not give you a threshold. It should be more than 120. Like every domain expert knows what is the threshold. So decide the threshold. You don't let the model decide. To teach the what we call as a data scientist to design it as per your. Point number 2, equally important, context-aware routine, right? The alert should not go, suppose a heart attack alert should not go to a nephrologist and a gynecologist for a patient who is sitting in a neurology ward. It doesn't mean anything. It's like a WhatsApp groups, right? Nowadays, we are seeing a lot more messages bugging up, and the true WhatsApp message will get burdened because you have 200 groups, hospital ward number 2 group, or 3rd floor east wing group, pathology lab group, tumor board group, cath lab group, dialysis unit 3 group. You are in 100 different groups and you don't know what to see. So the alert should be given to only the person who is going to act upon them. That is the second rule for the smart alert mechanism. Third thing is actionability check. If I get an alert, I should not be able to simply snooze it or stop it. Unless I act upon it and the mission reads it. How many times I'm overriding it? If I'm overriding it too many times, more than 40%, that means there is a problem with my AI algorithm. I need to go back, sit with the clinician. So this is how the rules for the clinician, raising the threshold, the rule for the admin, whom should the alert go, the rise in the ground staff, what is the action they have taken, the rules for the data scientist. That means if too many times I'm telling this is useless, I should stop giving the alert. This is what the alert design done by NHS Digital Design in 2021. By far, it is performing very, very good. Then comes the net benefit should be more than novelty. A simple early warning score with a clear protocol is much better than a complex deep learning model with no pathway. A basic question is, does it improve your outcomes? If not, it's just another advanced AI. Thank you very much. We can just play with it just like how we play the video games. The Muse score and sepsis, you may be getting bored with the same thing because I took one example to run you through those things. Simple heart rate, BP, respiratory rate, temperature, developed in 97. That means when I was about to complete my MBBS order. Actually did wonderful job compared to a multimodal design developed by a GPU using 78 features with a 91% accuracy, almost spending 85 lakhs for implementation per patient and 12 lakhs per year maintenance. Zero out. I'm not telling deep learning is bad. I'm telling that deep learning, if it is not smartly tagged, is of no use. So the golden rule of clinical AI is, does this tool change what we do? And does that change, is whatever change we do, is going to improve the patient? If yes, implement, measure, iterate, and improve it. If no, don't deploy. Even if it is 100% accurate, or F1 score is great. My last few slides before I just go to the real world experiences to be shared by our speakers from the US. How do I pair the action from the LM? 6 basic rules define the clinical outcome. Whether I want to delay the discharge or improve the discharge or reduce the readmission rate or chemotherapy dosing. You can take any example, define it, and it should be modifiable. If it is not modifiable, don't do research. It is of no use. So outcome should be predictable and modifiable. Then identify the lead time window. If it is 2 seconds, 10 minutes, no use, because no one in the world can act at that time. It should be enough, and it should be in the context of the disease, right? That means if at all stroke is there, if I can predict 1 hour before, it may not be of use because the window period is 3 hours. So it's like you should be defining those things and specify the action, have a protocol in hand, assign to the responsible person who should receive the alert. If you can go back to what we taught in terms of smart alert mechanisms, embed in the framework, keep on measuring the outcomes and keep on improving. Because these slides are available for review once again in the live stream. The pre-deployment checklist and administrative checklist is here with. I'm not going to read about it. You can go at your convenience. And once you apply this checklist into your real practice, you can actually use it in your real life scenarios. Small cases exercise. A 58 years old male, day 3 post-nephrectomy and surgical ward, applied the MIMI 3 protocol, showed high probability of neutropenic sepsis in the next 48 hours. You have a person, that means think about antibiotic cultures. Oncology nurse came, and the pharmacist came, admin came. Within 48 hours, lead time is more than enough. It's the best thing can happen to this patient. So the key takeaways today are: predicting an event has zero clinical value unless specific, timely action follows it. Each AI should have enough lead time to be able to alert almost well before the pathophysiological framework of the disease. you should not give too many alerts and cause alert fatigue. Admin workflow matters. Ultimately, the patient is better. That's what is the way to go. So, to conclude, AI is useful only when it changes what you do, and what you do improves the patient. Both of them are equally important. So the AI checklist before you put it into your practice is available. You can go through it. Thank you very much. Over to Dr. Kamala and Dr. Kiran. Um, thanks for accepting the invitation.
Hello, everyone. I'm Kamala Avancha. I'm your moderator for today, and I work with Arizona State University within the Educational Outreach and Student Services Division. Arizona State University is one of the largest universities in the US and ranked #1 in innovation in the US for 11 years in a row. My department focuses on supporting prospective and current students through a wide range of services from college readiness to ongoing student support. My work centers on improving the technology systems and experiences that help students navigate their journey at ASU, making services more accessible, efficient, and responsive so students can focus on their success. Today, we're going to talk about beyond metrics, clinical utility and outcome action pairing. The reason for this topic today is so far you've been learning about metrics, how to utilize AI, and the performance metrics using AI. But today we're going to focus on how AI is utilized within the clinical scenario and pair their actions to the outcomes within the clinical scenario. I'm going to talk about one particular scenario at ASU that we've implemented within the electronic health record system. Where when the physicians see patients who are our students, they spend more than an hour and a half a day daily conducting chart reviews, making note of the visit into the patient records. In order to reduce this clerical work that our physicians do and have them more focused on the actual patient care, we've implemented ambient listening which is an AI system which can listen to the conversation between the physician and the patient and automatically document notes, which then the physician can then review and ensure accuracy before it's put into the patient notes. Through this option, we are also trying to expand this, scale this to another system, which we call agentic AI, where AI acts as an assistant that captures all the data about the patient before the patient walks into the room with the doctor. All of their information that is relevant to their visit is brought in front of the doctor and synthesize and care for the patient. So basically, what I'm trying to say here is AI. Think of AI as an augmentation, not as a replacement for what our physicians do. We need to start with eradicating the clerical burnout that our physicians face today through the use of this AI as an augmentation, as an AI assistant, rather than a physician themselves. So the synergies between the physician and the AI is more critical than ever. And to talk about that, I'm going to hand it over to Dr. Kiran Avancha, who's the Chief Innovation Officer at HonorHealth and also an Associate Professor of Clinical Practice within the John Shufel School of Medicine and Medical Engineering at Arizona State University. A little about Dr. Avancha. He's a dynamic leader in healthcare and biotechnology, bringing 20 plus years of expertise spanning healthcare operations, biotech operations, corporate ventures, clinical innovation, entrepreneurship, and business strategy. His career is distinguished by a commitment to driving innovation through drug development, clinical and translational research, healthcare research, medical device development, and breakthrough product strategies. This innovative focus is grounded in a strong record of venture creation and strategic mergers and acquisitions. Dr. Avancha, all yours.
Thank you. Thank you, Mrs. Kamala. This is very exciting in terms of the topic itself in regards to clinical utility and metrics, and beyond the clinical utility and metrics is the topic for today. And as Mrs. Kamala alluded to the fact that there is a significant burden right now on healthcare workforce in general, especially due to various non-value added tasks that each and every one of these clinicians as well as employees within a healthcare system work to bring in care for patients. So some of these non-value added aspects are still important when it comes down to clinical utility itself, because that data sets are used towards operational efficiencies, and we need to augment some of this aspects. So I will tell the topic for today's discussion. I'll weave through some of the aspects when it comes down to HonorHealth. Who are we as HonorHealth system? What type of AI tools and applications that we have been utilizing within our own workforce, within our own organization? What kind of outcomes have we looked at or seen as some of these AI applications were implemented across? Some of them are in experimental stages, some of them have matured, but a lot of it is driven through the strategic focus for our health system at large. And as the Chief Innovation Officer for a health system, my job and my role is always to look at the innovation that's coming up in the healthcare in general, and see how some of these innovative approaches are being utilized within the organization. Now, I'll preface this with saying that there are always limited resources. There is this finite amount of resources and finite amount of hours in a day, and there is an increased demand in healthcare because there is the ubiquitous availability of information to consumers nowadays, and there is a huge consumerism on rise where a patient goes directly to Dr. Google, right? So if with the advent of this level of information, the patients are equipped with significant amount of data that with which they can bring in their own questions back to the health system consumer, the clinicians at large. So health systems need to balance these competing demands, both from the consumer standpoint of view, which is the patients, as well as from the payer standpoint of view, who pays for such services, and the requirements on documentation, requirements on balancing with these available resources internally, both for manpower as well as existing infrastructure, is the key. And that's where artificial intelligence is meant to happen, as we all agree. It's to alleviate the burden on information overload, to alleviate the burden on these complex mathematical calculations and modeling, in solving the giant jigsaw puzzle of healthcare in general. So AI is here to stay. There's no question whether AI is there or not, or have we arrived? Yes, we have arrived. AI is here to stay within the health systems, and how we utilize it, not just only on the clinical standpoint of view, but also beyond these metrics as such. Why do we need to implement AI? And we at HonorHealth focus less on AI for the sake of AI itself. We focus more on what type of operational problems and clinical knock-on effects are we looking at. So as a health system, I just want to give you an overview of who we are. We are a not-for-profit health system. located in Arizona, in Maricopa County. We're the second largest health system here. We have over 9 acute care hospitals, and we're committed to building healthy communities, personalizing care, and redefining expectations of high quality healthcare in general. We have an amazing research institute, outpatient surgery centers, cancer care network, largest here in the Phoenix metropolitan area. We also offer behavioral health aspects. We have a foundation, we have community programs at large, academic and military partnerships, as well as innovation platform as such. Next slide, please. On a quick stats, the scale at which we operate, we have about over 70,000 plus employees within the organization, over 4,000 physicians. So we have a huge internal need within our own workforce to bring in AI to augment them and have them individual capabilities, increase their individual capabilities to practice at the top of the license. We are a $4 billion plus net revenue organization. We see over 3 million patients annually that go through our walls as such. So there is a huge numbers when it comes down to operations within the walls of a system such as this. And therefore, that's where we look at AI as an opportunity for increasing operational efficiency and improving patient care access as such. Next slide, please. And we look at innovate, and this is our footprint of where we are across a 100-mile radius within a 100-mile radius in Phoenix metropolitan area. This gives you the breadth and scope of our operations across a pretty large city in Arizona. Next slide, please. And we look at innovation as a platform itself, and we have various pillars on that innovation platform. It's not just our internal process improvements or our research and development as such, but we also look at Honor AI. Honor AI is a strategy that's being built across on our innovation platform, both on the process innovation, product innovation, and business innovation side of things. Next slide, please. So what are we committed for? We as a health system are committed for providing innovative medical technologies and practices. We're patient-centered in our approach. We integrate it with our community health priorities. And AI implementation, technology implementation is here to stay, as I mentioned, and we have had several experiences in that landscape itself as an adoption of some of these transformative technologies. Next slide, please. So some of this is around where we have focused our approach on. What are the publicly referenced AI initiatives at HonorHealth as such? Because things that are publicly available, we are happy to share. And we looked at AI from solving some of the operational problems. As I mentioned, let's say shorter wait times within a health system, faster discharge planning, or better operating room usage and less staff burden. All these are potential low-hanging fruit opportunities that we looked at. And for that aspect, we have utilized something called Qventus. Qventus is an AI application. Qventus is a company that was building peri-op and operating room AI applications, which is a foundational model within the healthcare itself. And we have collaboratively partnered with Qventus, and this is all publicly available information as such. Can you go on to the next slide, please? Because we integrated it for increasing our operational efficiency, as I mentioned, optimizing our hospital workflows, improving our operational efficiencies, enhancing our patient workflow, reducing wait times, and streamlining some of the hospital operations. So a lot of these are very, very low-hanging opportunity that artificial intelligence can augment our existing infrastructure and existing applications within the health system itself. Can we go on to the next slide, please? And using that, this is publicly available information in regards to one particular application called Qventus. With using this AI, we were able to reduce our length of stay for our patients within the health system. And length of stay is considered a valuable metric in hospital operations. If you reduce the length of stay, operational efficiencies can get increased, as well as the cost burden on cost structure for health systems reduce. And if you look at with a quality discharge, we're able to save over 50,000 plus cumulative days in utilizing this particular AI application on the length of stay itself, as well as we were able to discharge 86% of our patients early. And that has brought in a significant clinical utility of additionally operating 3.3 additional cases in an operating room per month. So if you extrapolate that into annualized contribution margins, it's over $3.3 million. $3.8 million worth of annualized contribution margin. So these are all the metrics that AI was able to generate for a particular problem that we have gone to solve, especially the perioperative aspects of it. So this is mainly indirect but meaningful when it comes down to the clinical utility itself, because we're by improving the discharge rate predictions, our care progression, flow prioritization, we're able to have our teams make faster decisions and reduce avoidable delays in care cost. We go on to the next slide, please. We're also implementing, as Mrs. Kamala Avancha has alluded to the fact that ambient listening is an application that they are implementing within their own student health services at Arizona State University. The HonorHealth system has partnered with Arizona State University Health School, as such, their medical school, in bringing some of these innovative technologies into the patient side of things, as well as on the medical school side of things. What is ambient listening? Ambient listening is a well-known application of AI within the health systems, where there is a real-time interaction capture between a patient and a provider. Of course, it needs to be consented, so we had to take into some of the legal aspects and ethical aspects into consideration when we implement such kind of technologies. And the technology itself is able to automate some of the clinical documentation, reducing that manual entry for these clinicians as well as the nurses, and reducing the administrative workload for some of these providers. And we have started seeing a significant improvement in their workflow itself, as well as patient engagement. Right now, the physician doesn't need to keep seeing the screen when a patient is speaking to them. Instead, they could be concentrating more on the patient side. So it improves the patient interaction as such by automating some of these documentation, and it's increasing the patient satisfaction as well. So it's all not just on clinical utility or as metrics, but beyond all these aspects, there is the improvement in patient care quality and patient satisfaction. Can we move on to the next slide, please? And I shared with you a few of these low-hanging, immediately solvable opportunities within the health system. I spoke about the perioperative aspects of things. I spoke to you about the clinical applications when it comes down to the documentation on listening, ambient listening technology. Now, if you bring more of the AI applications or platform methodology into a number of operations within the health system, every area could be optimized when it comes down to the cost savings itself, or optimizing inventory within the health system, or staffing efficiencies itself, or predictive maintenance. As such, each of those are operational aspects in which AI can play a significant role in bringing in savings, whether it's reducing unnecessary medical tests, or allocating appropriate staff as such, There is also the telemedicine aspect that we have implemented within our own walls that is reducing the burnout amongst our nurses. We have seen that as a significant improvement. So when we look at all these AI wins, we look at what's the return on investment of a particular application on physicians, what's the return on the investment, and how do we measure that for our employees, and how do you translate that into efficient patient care itself. So it's these three buckets in which we look at each of these AI's returns as such. Can we go on to the next slide, please? And you all must have seen how it can improve the workflow automation or heard about process simplification using some of these routine task automation and staff productivity increase. But a lot of that has to have a meaningful impact on enhancing some of the patient care. Now, it has to efficiently show gains as such. We're clocking towards 30% reduction in some of these administrative task time after implementing certain automation aspects within our own walls, whether it's using AI in revenue cycle optimization, whether it's using it in our scheduling aspects as such, and centralizing some of these AI applications within our navigation system. Can we move on to the next slide, please? So on a high-level clinical application, we have had our own internal sepsis monitoring and sepsis alert system within our own EHR, electronic health record, that's been built by Epic. We have started utilizing its AI capabilities and within that, and we're now able to start seeing some meaningful results in sepsis risk alerts. We're able to start showing that to our clinicians, which is helping significantly on the decision support, clinical decision making. Because as I said, there is a humongous cognitive overload on alerts as such amongst the clinicians when they are treating complex patients, complex care, providing complex care in intensive care unit or in the inpatient units. So how do you reduce the burden with these decision support systems? And that's where the AI applications are moving towards. It's also not just reduce some of these by providing decision support systems, but also how do you personalize some of these training for competencies in our workforce on education and onboarding for some of these new applications is something that we started taking into consideration. So we have to balance out our workforce satisfaction. We have to balance out their retention. We have to reduce their burden, increase their efficiency itself by augmenting some of these latest technologies, AI technologies, with the current clinical workflows as such. Can we go on to the next slide, please? So beyond that, where does AI can improve or enhance patient engagement and patient satisfaction or patient communication? So we looked at some of these aspects of applications of AI between the interaction between the health system and the consumer, the patient itself. We looked at an application called Hippocratic AI. It's a foundational model built for health systems, especially around AI-enabled communication aspects. It's a virtual assistant and automated messaging for between interaction between patients as well as the health system in general. So typically it used to be a nurse or a navigator who needs to go ahead, pick up the phone and call a patient before the patient walks into the health system for his or her care. That interaction is now being switched with AI application, switched to AI application where the AI chatbots are able to effectively communicate with the patients And this platform is able to help them in easing their appointment scheduling as well as sending their reminders as such, so that there is an increased engagement between the patient and the health system. And there is also this interaction between multi-channel patient interaction that is effectively taking place using some of these AI applications and implementation. Can we move on to the next slide, please? So what are the ethical, legal, and social considerations that we at Honor have started taking into consideration, not just on the metrics as well as the clinical utility? Next slide, please. So we took several aspects into consideration. We have to take data privacy aspects into consideration. We have to take into security measures into consideration. It's about monitoring our staff and for training purposes without breaching any data governance frameworks that we have built. We have to adhere to specific HIPAA regulations and laws and legal protection and ethical data handling of the aspects using AI. We have to ensure that there is data encryption and access controls in place for AI systems to be effective. And we also have to have clear data handling policies to build the patient trust and mitigate any of the legal risks that it could arise from. So we have to look beyond some of these, this is a cool application. Yeah, we could go ahead, it's providing utility, versus we have to take into consideration some of these aspects of data privacy and security measures deeply so that we could build the trust with our patients in general. Can we move on to the next slide, please? And we have to bring in ethical AI, equity in AI-driven healthcare systems. Equity is one of the key aspects to reduce AI biases. So we need to make sure that these data sets are continuously validated so that we're reducing bias on an AI healthcare algorithm. So we want to have an ethical AI adoption, and this is still an ongoing effort within our own health system, as well as in any other health settings in general in US that we know of when it comes down to ethical AI adoption aspects of it. Next slide, please. And we have to build in trust, transparency, trust, and regulatory compliance. Those three are key aspects in any AI application. Regulatory compliance is becoming more and more important because, as I mentioned to you about the sepsis application, without strong evidence-based clinical application data sets that have strong signals, you'll not be able to implement some of these AI applications in for clinical decision support. So there has to be this regulatory compliance. How do you approve a drug or a device? So taking some of those basic tenets and the principles of drug approval, the AI applications are now treated software as medical device applications, and FDA regulations and emerging standards are coming into from a accountability and safety aspects in this. That builds a much needed patient trust into some of these applications as such, as ethical AI is coming along, and there should be this patient acceptance. Without the patient acceptance, there is no application. Beyond patient acceptance, you cannot bring in an AI application that's not accepted by patients at large, even if it is improving your own internal clinical burden, reducing the clinical burden itself. Can we move on to the next slide, please? So future direction and what are the lessons learned so far for us? Next slide, please. Scaling of these successful AI initiatives across HonorHealth. So what we have to take into consideration is, okay, what is working well? What is not working well? How do we take some of these models that are working well and replicate this across to maximize benefits? And we constantly have to look into the requirements of our data infrastructure and effective change management to ensure that there is a scalability within these AI applications. And sometimes we have to test pilot some of these in a pilot projects. But beyond pilot projects, we have to customize in certain aspects of some of these applications in general. We have to prepare our staff for these AI applications at large, for a smooth AI adoption. There will be friction. We have to maintain the message in regards to AI is not replacing humans here. AI is augmenting humans to enhance their capabilities, to bring in the much needed efficiencies that otherwise a normal human may not be able to achieve just by himself or herself. Can we move on to the next slide, please? And so we started taking that very seriously, and we have to, as health systems, we're not technology firms, so we have to partner efficiently with technology companies. We partner with a number of companies to co-develop some of these innovative AI health solutions. We validate some of them. We build in this partnership with academia, like Arizona State University, Mrs. Kamala Avancha's university down here, and I also hold a associate professorship within the New School of Medicine at Arizona State University. And this academic collaboration helps support research and development in some of these advanced AI models and data sharing frameworks. And also working together as a consortia, we're partners with over 20 plus large health systems that comprise of sharing, and sharing their EMR health data sets across a de-identified manner on a platform where broad data set sharing has now been seen as an important tool both by FDA as well as by Centers for Disease Control here in the United States that can increase and accelerate AI adoption across the healthcare sector in general. So we have to achieve some of these collaborations through continued innovation as such. We move on to the next slide, please. So what else we need to look at? We have to look at constantly the feedback, whether it's clinical, operational, and patient input. You have to look at the continuous feedback loop. How's it defining our AI performance? Your AI performance has to be constantly monitored, because your benchmarks are going to be changing, increasing, and to track effectiveness, we have to put in guardrails around that to make sure that there is a continuous improvement within those models. And also this adaptive model updating. See, there is in the clinical environment, when emerging new evidence is coming up, new research and new data is coming up, we have to ensure that some of these models are adaptive and they themselves are increasing within this, so that it's not based on old data sets or outdated models as such. So you have to include this adaptive model updating within this continuous evaluation. Can we move on to the next slide, please? And so in conclusion, AI's transformation power for a holistic environment, healthcare environment, is one, we have to look into the enhancement of the clinical care, as I said. We have to look into the operational efficiencies. We have to look into the patient engagement and ethics. And obviously, we have to be cognizant about the continuous innovation and collaboration, so that you have to maximize AI's impact in healthcare evolution. We're in the nascent stage. We're on the platform right now. We're on the first steps of this platform. More to be built on this AI revolution and AI platform as such. And for that, adoption is the key, adaptation is the key, evolution of within a health system, both from a workforce standpoint of view as well as patient expectations are changing. So you want to ensure that all these are being put into this puzzle to solve the next frontier challenge in healthcare, where you want to see that pie where AI is now able to automatically diagnose, is able to enhance treatment efficacies and effectiveness by utilizing some of these large data sets as such. So that's the futuristic way in which we will be moving towards as AI evolves within the healthcare. So I'll pause there, and we're happy to take any questions. And thank you very much for the opportunity. So Mrs. Kamala Avancha, back to you.
Thank you, Dr. Avancha.
So thank you very much for the presentation. I have been seeing a lot of questions in the chat box. But this is not a sponsored project, and at NBMS we maintain very high ethics. There are
regarding whether the ethical and any other aspects are there. Is anyone using it in real time? What is happening across the globe? Examples. So we thought of doing the research, and not everyone is willing to share what they do openly in the world, right? So with a lot of difficulty, we could convince. We apologize if at all some part of it appears to be promotional, which is not the case. At NBMS, we never promote anything, and neither the speaker is trying to do that. He was just sharing his experience of what he's doing in real life. So this is what I just want to say. The comments, I just want to address those things. I hear a few questions in the comment session regarding the application, ethical aspects. We can discuss a lot of them. To answer the questions, give me the names. The names are already with you here. Hippocratic Act, the legal and ethical aspects of it. Ambient listening to document the conversational history. It sometimes can hallucinate. We don't deny that. Even if you listen to the first lecture, Dr. Nageshwar Reddy told, Mera is a thing which they use it in AIG hospitals. A similar thing was used by a different set of people in the coastal Andhra Pradesh called what we call as Anna, Dr. Anna, and someone in the western parts of the India are also using it. So we're not here to promote. We're going to educate you what are the available options. But when you choose an option, ensure what metrics should be assessed before you adopt. Gave you the examples. It should be attached to a protocol. There should not be a tick of 2 minutes. Actionability have to be linked. So with these things, with these constant applicable or application things, the metrics have to be looked into. But these things, I thank everyone for actively attending. Thank you very much.
Thank you, Dr. Suresh, for this wonderful session. And thank you all the participants for joining the session. Thank you all of you. Thank you so much.